So one way to see the difference between algebraic pieces is actually having shapes, or in our case, we're going to use algebra tiles. So when I have algebra tiles, I'll just need to make sure I can define what these algebra tiles are. So these little squares, we're going to call +1. So the green is going to be positive and the white is going to be negative. Now, I'm not too picky as long as you are consistent. If you do a problem, then you do all your positives white and all your negatives green. No big deal as long as you're consistent. Okay, in your textbook it sometimes switches as well, and when we deal with algebra tiles, we just need to define what's going to be your positive, what's going to be your negative. And once you've done that, as long as you keep consistent, it's not a big deal. So our small squares are going to be +1, are going to be ones. Green is going to be positive, white is negative. Our bigger tiles are going to be our x tiles, or variable tiles. So the rectangle is going to be our x tile. And with the x tile, we have to understand that there's a length and width that goes with this area x, because these algebra tiles represent area. So when I say +1, it's because it has a length of 1, width of 1. -1 because they have a length of 1, width of 1. When I have an x tile, it's because my length is going to be x, my width is going to be 1. So 1 times x gives me 1x. The square tiles are our x squared tiles, and they should be one way to help you kind of remember. If it's square, we have a squared factor. So here, the length is going to be x, and the width is going to be x. Okay, and that gives us an x squared tile. The same thing is going to go with the negatives, but the negatives are just going to be the opposite color. So when we draw these out, make sure that you're able to draw these out using tiles. So if I have 2x squared minus 2, I need to actually show two tiles that are squares, which represent my x squared tiles. Okay, and we're going to shade that in because we've decided that the shaded one is positive. And we need two of them. Okay, so there's my two positive x squared tiles, and I need to show two -1 tiles as empty ones, or white tiles. So our negative x squared needs to be a square. It's going to be the big square. Okay, but it's going to be empty, so that's going to be our negative x tile. Our 3x are going to be our rectangle tiles. Okay, so that's 1x, 2x, 3x, and then we need to show our -1 tiles, and we need to have two of them because we have -2. Okay, so this one here, x squared, 2x squared plus 3x, well, it means I have to draw my two squares, and they have to be filled in. Okay, there's my 2x squared tiles. And my x tiles are going to be like this. I have three of them. And it's very important that you make the length here the same as the length of the x, because they have to match. Those edges need to match. Okay, now this just happens that we can actually show this in a rectangle. And if the rectangle, we know that the area is going to be made from a length of x, and this width is going to be 2x, not 2x squared, because remember the lengths are going to be in x's. That's 1x, 2x, 1, 2, 3, not x's, but 1's, plus 3 1's. Okay? Here, x squared, we have two of them again. Now these two x squareds and the 3 1's, there's no way we can put them into a rectangle. Okay? These 1's edges will not line up with the x edge, so we can't arrange this in a rectangle. And the reason why I'm saying talking about putting in rectangles is because if we can put it in a rectangle, that means we can factor them, put them into factor form. So here's my expression is going to look like this. I have 2 squares. Okay, so I'm going to have 2x squared tiles plus 3, well these are x tiles, so I need to write it as 3x. And again, you can see that they're arranged in a rectangle. This one here doesn't look like it's arranged in a rectangle, or can be, so I need to count it up. So I have 1x squared, I have 3 x's, but I'm taking away 2, adding 2 negative 1s, or minusing 2. Here, before I write it all out, really, I should simplify this because there are some 0 pairs involved here. So 0 pairs are when I put these together and I get a 0. So x squared and negative x squared cancel each other out. A positive x and a negative x cancel each other out. So really, I'm just in a way I'm combining like terms because I'm counting the same shapes together, but some count against each other, so we can actually get our 0 pairs here. So once I've done that, now I'm ready to write my expression. What's left over is 1x squared. I have 2 positive x's, and I have 4 negative 1 squares. So same thing here, I want to combine my like terms. Okay, I want to find my 0 pairs. There's a 0 pair. Okay, I have another 0 pair here and here. Okay, these can be made into 0 pairs, so I can get rid of those. Now it's starting to get a bit messy, so I just got to be careful when I count it up. So it looks like I have 1 negative x squared left over. My x's I have positive. I have 3 of them. And my 1s I have negatives, and I have 4 of them. So there's my expression. So why do 3x and 4x squares not combine? Well, they are different shapes basically. Okay, that's really the simple way we can explain it. So there's different shapes, therefore cannot be combined. Okay, so if I try to count this shape and this shape together, well, it doesn't make sense to count them the same. I can't say I have 2, what would I be saying, talking about? 2 what? Yeah, I can talk about 1 rectangle and 1 square, or 1x term and 1x squared term. I cannot combine these shapes together. Okay, so that's very important that's a very important piece of it. That's one of the reasons why we use algebra tiles, so we can confirm these things.